Hey guys, all right, the last couple weeks we have been talking about rates, ratios, and proportions, and today we're going to switch gears and we're going to talk about percents, which a percent is a ratio, but more specifically it is a ratio that has a denominator of 100. So go ahead and write that under what is a percent, a ratio that has a denominator of 100. That word percent means per 100. So we're still talking about ratios. We're just talking about a specific kind of ratio now, and that is a percent. Now, we're already very familiar with percents because we deal with percents every day when we figure out our homework scores, and all of your grades are in percents, and we see percents all over the place in our everyday lives. And we'll talk about that a little bit more in class, some specific examples. But a percent is a ratio that has a denominator of 100. So if we were to say 85%, like we see in this picture here, that would be 85 out of 100. Or we can also think if we do 85 divided by 100, that would be 85%. All right, so this first part here wants us to write the percent as a fraction in simplest form. So 29% would be 29 over 100. And that can't be simplified anymore, so that would be 29% as a fraction. 45% would be 45 over 100, but this one can be simplified because I can divide the top and bottom by 5, and I get 9 over 20, which would be simplest form for 45%. Now, when we have a fraction and we want to write it as a percent, before we can write it as a percent, we need the denominator to be 100. So in this example here, we've got to ask, okay, 10 times what would be 100? Well, we know that's 10. And if we multiply the bottom by something in order to keep the fraction or ratio equivalent, we have to multiply the top by the same thing. So 7 times 10 is 70. So 7/10 would be 70%. Our goal is to get the denominator to be 100. We can do that with this next one. We ask 5 times what is 100, and in this one the answer is 20. So whatever we do to the bottom, we need to do to the top. 3 times 20 is 60, and so 3/5 is equal to 60%. And so we can figure those out without even needing to have a calculator, because as long as we get the denominator to be 100, then we have a percent. So why don't you take just a couple minutes and try 1 through 4 down below. All right, go ahead and check your answers with mine. Make sure you got them all right. All right, so at the top of the next page, you see a table of common percents, and it says that you need to memorize these. Really, you want to be familiar with these because these are the percents that you see most often. You are rarely going to walk into a store and they say that everything is 37% off. That's just not a common percent that we use. And so these percents are the ones that in your everyday lives you will see most frequently, and so the more familiar you are with them, the easier it will be. Now, another area that we can talk about and use percents is with probability. And so the next couple problems we're going to do are just very, very basic probability. You might have done probability before, but when we find probability, we are putting the number of desired outcomes, in other words, the number of things we want, over the total number of outcomes, the total number of things that could happen. So, in this first problem, it says a computer randomly generates an integer from 1 to 10. Find the probability that 8 is the integer generated. Well, how many desired outcomes do we have? Just one, because I just want the number 8, so that's only one thing. How many total outcomes do I have? That would be 10, because you could get any integer from 1 to 10. But it wants me to give this as a percent. So again, I need to get the denominator to be 100. So I multiply the top and bottom by 10. I get 10 over 100. So that would be a 10% chance. But when we have probability, here's how we write our answer. Our label actually comes on the front end. We use a capital P for probability, and then we write in parentheses the event that we want to have happen. So in this case, that would be generating an 8. So this would be the probability of generating an 8 is 10%. Again, the label comes on the front end when you have probability, and all of this would be your answer. Let's try another one. Number 1 says a radio station randomly selects 1 of 5 finalists for a prize. You are one of the finalists. What is the probability that you will win? Write your answer as a percent. All right, so how many desired outcomes do we have? That would be 1, just that you win. That's your one person. How many possible outcomes? There are 5. So to figure out what this is as a percent, we need the denominator to be 100. 5 times 20 is 100, so if I multiply both the top and bottom by 20, I have an equivalent ratio. So that would be 20 over 100. So my answer is that the probability that you win, so again, I write that P and then in parentheses, my desired result would be a 20% chance. Now let's try number 2. What is the probability that you will roll an even number on a dice? Now a dice, remember, has 6 sides, so there's 6 possible outcomes, and it's the numbers 1 through 6, so there would be 3 even numbers, 2, 4, and 6. Now at this point you might be thinking, well, 6 doesn't multiply to 100 with a whole number. So this is easy. We can just simplify this to 1 over 2. And then multiply the top and bottom by 50 to get 50 over 100. So in this case, it'd be the probability, so remember capital P, of rolling an even would be 50%. In other words, half the time you roll a dice, theoretically, you should roll an even number. Why don't you take just a second and try number 3? All right, check your answer with mine. The probability of generating an odd number in this case should be 50% because it would be 5 out of 10 times. All right, next you should move on and watch lesson 7.3 on percents and decimals.